Welcome, this is the third video on sequences. This is our third task. If you've been in class, you're starting to get really comfortable with both the arithmetic sequences and geometric sequences, I hope by now. Take you back to those just a little bit, just to review. We've discovered geometric sequences. It's when we see a multiplying pattern. Even if it's multiplying by a fraction, it's getting smaller, or a multiplying pattern where it's multiplying by whole numbers and getting bigger. Or a number larger than 1, I should say. If your growth factor down here is larger than 1, then it will be a growing sequence. If it's less than 1, then it will be a decay sequence, okay? And we discovered the recursive formula for it, the explicit formula for it, and then we went into, in class, the exponential link. Exponential functions are just simply a limited domain, and an exponential function is a geometric sequence because our sequences start at the first term. So our domain is very limited. You will see a curve in their graphing. And in class we talked about the exponential function rule being y equals a b to the x, and how that's related to our geometric sequence rules, the recursive rule and the explicit rule. And then the day before that we did only arithmetic sequences, which are sequences that you see an add, or you might think subtract, but it's add a negative from one number to the next. I don't know why I don't have one written. Oh, no, that was one. Anyway, but that's what you see with arithmetic sequences, is that it's adding or subtracting. We have a recursive formula we've developed there, explicit formula we've developed there, and in class we connected it with linear functions. Again, it is a linear function with a restricted domain. So today, what we really want to do is just get prepared to come to class to play a little bit more with these. So let's think about this with our sequences. We went two different directions. We went arithmetic. Again, that was adding. Let me just give you a simple little 60, 80, 100, 120, 140. That would be a simple little sequence. We'd show that it goes on and on. Remember, the reason we do sequences is for the power of prediction. In banking, you can make a lot of money if you can predict things for companies. So looking at this, what is my common difference? Well, I would hope that you would say, oh, well, that's going to be 20, plus 20. So now, looking at the recursive rule, again, if you have not been to class or have not seen the first two videos, get on there and watch them, because I'm not going back and reteaching this morning. The recursive rule, remember, is when we can choose any position. That n would be a position in the sequence, and we take the first, recursive would be the previous term, and we simply add to it the common difference. Okay, so in doing this, we have to have the previous term, and we have to know the common difference. So for this particular one, if, let's say, we're looking for the fourth term, we would have the third term plus 20. Now we need to know the third term to find this fourth term. So we go 1, 2, 3 terms. There's 100 plus 20. And sure enough, we would get the 120 in the fourth position. Okay? Now, that's the recursive use. And really, you only use it when you're up here predicting the next one. It's not really useful back in here. Explicit is when we can use the first term, and we don't need to go clear out there to find the previous term, because sometimes we make mistakes when we do our repetitive math. So here we use the first term, and we simply multiply the common difference by the term number minus 1. You might say, well, why is there that -1? We've discussed it in class. I'm going to go over it again here. Let's just look simply at the third term. We start at the first term. Going to the third term, we only use 2 common differences to get there. So it's 3 minus 1 will give you the 2. Okay? So with that, I just want to encourage you to play around with these a little bit. You don't need to follow formulas that have been discovered already. I'd like you to just develop a little bit more and maybe be able to go from the, let's say, 3rd position to the 7th position. I want your group to practice that and see if you can develop a formula tomorrow in class. 3rd position to 7th. Can you give me a formula for that? I'd like to see you work that out. I'm going to give you some tips here in this film. First, I also want to talk about, okay, I'm going to give you an explicit formula, and I want you to come up with the recursive. Okay, so let me just give you an example of this. Let's say that I don't want to use that one because I want you completely unaware of what this might be. Looking in my notes, here's my explicit formula. F of n equals 2 plus -3 times n minus 1. Well, first thing you want to look at this and say, well, what does that really tell me again? Remember, the n minus 1 is simply whatever position you're looking for, but that -3 is your common difference. Okay, so in recursive, we know right now that we would take this formula and we would say, okay, take the previous term and add to it this -3. Now this is our first term. So in recursive, we do have to note that our first term is 2. And there you go, there's the recursive formula for that sequence. Now let's say that I give you the recursive and I'm asking for the explicit. So in recursive, again, I have to define my first term. Let's say it's 5. And here's my recursive formula. F of n equals Fn minus 1 plus 12. Now hopefully you just look at that and say, well, I really only need 2 bits of information. The first term and the common difference. And I write my formula. F of n equals f of 1 plus d times n minus 1. So it would be f of n equals my first term, which was 5, plus my common difference, which is 12, times n minus 1. And now I could use any of those formulas in any way on discovering the next part of the sequence. I know this might be seeming a little bit mathy today, so I want to bring it back to some real world stuff. Let's say that you're going to go on a rafting trip. So you're picturing your raft floating out here on the water. Put a little oar next to it. And you've called the rafting company. And they said, well, if it's just one person going, the charge is $75. If 2 people go, then the charge is $100. And if 3 people go, then the charge is $125. And you start thinking about this and you go, now wait a minute. Okay, so I'm going to predict how much is this increasing. Think of it like a sequence, 75, 100, 125. How much am I adding? If you're saying plus 25, bingo, I agree. So for my fourth one, you would probably just in your head use the recursive formula and you would say, Well, let me take the previous one, 125, add 25, and I get 150. So if you're like me, you're starting to budget this trip and going, man, if I go alone, it costs me $50. If I take one person with me, it costs me, if I go alone, it costs me 75. If I take one person with me, it costs me 50. If I take 4 of us, oh my gosh, I'm going to save even more. What is this? It's about $37. This is getting good. So you start calculating it out and you say, well, this is the total cost of the trip for 4 people, but then I can just divide that by the number there are. So I'm a little bit curious, I could take and I could graph this. And I could say, okay, at 1, I'm up at 75. 2, I'm at 100. And I could just figure out, using my linear graph, where my maximum number of people and my minimum cost would be. Now, your maximum number of people is not restricted by this domain. It's restricted in real life. It's restricted by the number of people in your raft. Because see, as you start loading it up, the water level starts rising. And guess what is happening to that raft? So that's how we can use it in real life. Just a good power of prediction there. That's really nice. So on the graph, let's look at the linear function. We've already discussed that our common difference is our slope. So we know y equals mx plus b. It's y equals 25x plus, what is that, b again? Remember, we extend it one more time out this way. In other words, we're going backwards on our sequence. 25 less than 75 would be 50. So there's our linear. This is our explicit. Oh, I should have 4 minus 1 there. And the last thing that I'd ask you to do in class is to prove to me that these are the same. So I'd like you to switch that to Fn, this to n, and you would have let's see, Fn equals, let's go with the explicit formula here, which would be 75 plus 25 n minus 1. And I want you to set your explicit equal to linear and prove that they are the same thing. So we have 75 plus 25 n minus 1 equals 25 n plus 50. Please go ahead in your notes and prepare for that. In class we'll be doing a lot of those, just making sure that we are within the function, that we're still abiding by the same thing. Now the last thing that we're going to do in class is I'm going to give you another little real world scenario. You had someone come out and check your well. I know that looks like a t-shirt, but it's not. It's a brick well. Here's the back side of it. And down in this well, the water level, you had them check it, but you forgot to write down what the water level was when they checked. 2 weeks after they checked, you noticed that the water level was at 57. Now, suddenly, you check it again at 6 weeks, and you notice the water level is at 45 feet. So you are a little bit concerned. My water level's going down. Is it going to last to the end of the growing season out here? It's not a well that you're using at your house. It's out in a pasture somewhere. And so our question comes to this. Well, we come back to the math drawing board. You call the company, you say, hey, I need to know this. They say, well, we don't keep those records. And you say, well, I really need to know what it was at the start because I can't get any insurance funding, any help funding this unless I know how we started and I know where this is going. I've got to be able to predict if we have enough water. So I suggest that you use a sequence. Come back to our math class. You say, this is 2 weeks in. Let's put it in the number 2, the A2. Now remember, we also called that F of 2. This is just another way to mark it. And that's at 57 feet. Over here it's 6 weeks, so this is 2, 3, 4, 5, 6. At 6 weeks you have 45 feet. Now we don't really put the units in the sequence. I shouldn't have put it there, but this just gives you a picture of what you're thinking about. Okay, so I'm adding a negative number because it's going down, and I need to discover what that negative number is. If we take, just like we have on explicit, and we say, well, let's take that 6th term, we know that it could be the 2nd term plus whatever this d is. And how many of these are there? From class, you should know that it's 6 minus 2 because of these positions. 6 minus 2, which would be 4. So now we say, let's plug in numbers, 45 is equal to 57 plus whatever that difference is times 4. Well, now doing the math, we get a negative 12 equals 4 times d. Divide by 4 on each side, and we find that we're losing 3 feet a week. Now, in order to call the people funding your ranch, you need to explain what the well started at, not what it started at 2 weeks. So it's easy to do just visually right here. It's fine with me if you do visual drawings in your math, but I also want to show you with the formula where we can go with this, and that is basically that we can just now say, okay, I need to find what A1 is, and I can do it again with my formula here. You could do recursive. Well, no, you can't do recursive on A1, but you could do either one of these. So I'll do the easier, A2 plus negative 3 times 2 minus 1. $57 plus negative 3 times 1. A1, and I'm sorry, I did that backwards. It should be 1 minus 2. Now we see how come it's important here. The reason that is that I would have a lower number in my A1 position, but when you put it in the order that it is in the equation, 1, 2, 6, 2, 6 minus 2, 1 minus 2 is a negative 1, and now we get that positive number we need, because 57 plus negative 3 times negative 1 is positive 3. So we get the first one is 60. Okay? And now you can give me all the information that I need, which is what the sequence looks like. And I might ask for the explicit formula. Not sure what I'll ask you for in class. You need to know this stuff inside and out so that you can do whatever I ask. F of n equals 60 plus negative 3 times n minus 1. Right? That should do you well for class. We'll see you there. Have a great one. Bye-bye.